So in this video, we are going to be going through a revision of Chapter 7, which is Antidifferentiation and Integration Techniques for Specialist Maths. And hopefully, this is going to give you a bit of an overview of all of the different techniques. Some straight from the formula sheet, others, certain things like trig techniques, partial fractions. We're going to be doing U substitutions, changing terminals, and all of those things. So we're going to do that. Now, the first thing we're going to be looking at, though, is this one here. And if it's 1 mark, this is sort of, there's no real technique for this other than it's straight from the formula sheet. Now, straight from the formula sheet, you should be able to say that this is going to be an inverse sine or an inverse cos. Inverse sine, yes. Okay, straight away. But wouldn't the inverse sine, is it the antiderivative of 1 over the square root of 1 minus x squared dx? That's inverse sine, isn't it? That's inverse sine of x. So can you see there we have a 4? So it's not going to, so we need to bring that 4 out the front, wouldn't we? Okay, so if I had a 4 out the front, like so, that would be 4 inverse sine of x. But the problem is, though, is this little 4 over here. Now, thankfully, though, we've got an x squared, so that actually makes it pretty easy. So remember that on your formula sheet, does it have an x on a? Does it have a squared minus x squared? So what's a squared in this case? A squared is 4, so a is 2. So therefore, the answer, find an antiderivative, we could say an antiderivative is that f of x is equal to 4 inverse sine of x 2. Now it says find an antiderivative. So because it says find an antiderivative, we don't even have to do the plus c. Okay? So, because c can be anything. Does that make sense? All right? There's no need to do plus c. You wouldn't lose the mark, is what I'm trying to say. Okay, over here we're doing an antiderivative. So what we're going to do is we want to find over here 4x minus 1 cubed dx. And that is equal to, well, we're raising the power by 1, aren't we? So we're doing everything and we're leaving that 4x minus 1 to the power of 4. We're then dividing through by that power of 4, but what are we also multiplying by? 4, the chain rule in reverse. So instead of timesing by 4, we're dividing by 4. So what you should have is this 4x minus 1 over 4 over 16. Okay? Now, what do you notice here? What do you notice here with this guy? Can I just suggest that this is something that's not on the formula sheet, not on the formula sheet, but it really should be, or you should at least acknowledge that it's not on the formula sheet, but it should be, and that is this, f dash of x, and if I had, f of x, if I have something and its derivative, f dash of x dx, then that's going to be equal to log to the base e of f of x. What am I missing though? What am I missing if I was to write it like that? The absolute value sign. The only time you can drop that is if you can justify. So, can you see there, the 1 plus x squared, the derivative of that is 2x. So what we can do is, why don't we just do this? Why don't we change it? If you want to manipulate it, it's all about manipulation, this topic. So I'm going to make that 2x, and I'm going to make that 1 plus x squared, and then I'm going to bring out the front. I'm going to bring out the front a 2. So as you can see there, that thing inside the brackets is going to be log to the base e of 1 plus x squared, and then you have the 2 out the front. So therefore, we can say that I'm going to say big F of x, which is the antiderivative, is equal to 2 log to the base e. Now, why can I go straight to this and write 1 plus x squared? Why can I do that? Because it's squared and it's always going to be positive, isn't it? There's no way that's ever going to be negative. Okay, so I would also, by the way, just so you know, I would also accept this as well. If you had the absolute value sign, you wouldn't lose the mark. Okay, but you could omit that sign for that very reason we just discussed. Now, just you might recall that, and I've also given you the hint, we've got to find the antiderivative of sine squared x. Now, the thing is that sine squared dx, but if we have a look, there's no real way to do that. There's nothing on the formula sheet. But what you need to realise is that I believe is that cos 2x is equal to 1 minus 2 sine squared x. That's the double angle formula. So since we have this sine squared x over here, we can rearrange that double angle formula, which you can also put in your bound reference, and you can actually have it committed to memory if you wanted to, but you don't have to. I don't like doing those things sometimes, because imagine if you remember it wrong and then you recite it in the exam because you've remembered it and you got the plus or minus mixed up, and all of a sudden you lose the marks. It's silly. I don't think you need to. Okay, so what we're going to do is I'm going to get 2 sine squared x over the other side. 2 sine squared x is equal to 1 minus cos 2x. And then I'm going to say that sine squared x is equal to a half 1 minus cos 2x, like so. Now I've done that to the side, I can clearly then say with an equal sign that means that is equal to, I'm going to bring my half out the front, and I'm going to say that that's 1 minus cos 2x dx. And we can simply just solve that using the formula sheet now, can't we? Just a very simple calculation now. So what we're going to do is we're going to do that's a half, and then we're going to do that's going to be x, and the antiderivative of minus cos is minus sine, so that's going to be minus sine 2x, but don't forget that baby there. Okay, we've got to divide through by, we're doing the chain rule in reverse. So we've got to divide by 2, not times by 2. Okay, and if you can't differentiate, you can't anti-differentiate. Now, you know what, if you left it like that, that would have been fine. Or you can just sort of simply go x minus 2 minus sine 2x over 4. And since it's find an antiderivative, once again, no need for the plus c. Yes? No, absolutely not. That's fine. It's fine. But just not required. Okay? Because it's the find an antiderivative. C could be 0. So that's why. Okay, so are there any questions so far about what we've been through? No? I hope you're ticking these and getting these right. I'll give you the solutions, the handwritten solutions, but make sure you please make any notes now of any mistakes you're making or any tips that you hear from me today. Now, we've got over here, first of all, when you look at this, people, what students are going to think automatically is they're going to think, oh, the derivative of this is 2x. And the derivative of x squared plus 9 is 2x. And then they're going to try and somehow manipulate it. No. You need to split this up. Okay, so first of all, what we're going to do is, and you don't write nothing equals something. I know it can be a bit lazy. People can get very lazy with this. So what we're going to do is we're going to write this. That is equal to, split it up, 6 over x squared plus 9 dx. Don't forget to keep the dx, and that's between 0 and 3. And then we've got plus x over x squared plus 9 dx, like so, and that's between 0 and 3. Now, what you might notice here is that the one on the left is going to be what? What's this one going to be? It's going to be arctan. Now, but just remember, arctan Arctan is going to be in the form of, be very careful with this, I believe it's a over a squared plus x squared dx is equal to arctan of x on a. Is that correct? Yes. Be careful though. It's the a and then a squared, so you get to really be careful with this. So at the moment, what's a? What's a in this case? So a is 3. So what we can do then is, why don't we do this? You can if you wanted to do this in the one line, I have no problem with it. Okay, we need a 3 here. So if we need a 3 here, why don't we make it a 3? Because it's a 6, let's put a 2 at the front. Yeah? And it's not going to take you any extra. If you want to do it on the next line, that's fine. Now, all of a sudden, that's exactly how it should be on the formula sheet. So now we can go ahead and solve this. And this guy over here is going to be a log as well, isn't it? Because the derivative of x squared plus 9 is 2x. And we've got an x there, so we can deal with it constant. Why don't we do something special over here if you want to? Why don't we make this a 2x? Why don't we make this a 2x, which means what needs to go out the front? A half. A half. There's nothing wrong with you doing that in one line. Can you see that? Now we can proceed, and then that's how you can save yourself time and save yourself lines of working. You have not skipped a step there. Okay? You've clearly shown your method. Now what we're going to do is I'm going to go straight to this. I'm going to go 2. That is going to be arctan. We could write inverse tan like so of x over a, which is what, 3, is it? 3, and then that's between 0 and 3, and then we've got plus a half, and then we're going to do this again, and that's going to be log to the base e, and once again we can omit the absolute value sign because x squared plus 9 is always going to be positive, isn't it? So x squared plus 9 is perfectly acceptable, but I would accept the absolute value sign, no problem. And then we're going to go from 0 to 3, like so. Now, what we've got to do is evaluate. So 2 times, so arctan of 1 is pi on 4, isn't it? So that's 2 times pi on 4, which is pi on 2. Now, arctan of 0 is 0, isn't it? So well, that's going to be pi on 2 minus 0, if you like. Pi on 2 minus 0. And then we've got plus, let's keep the half at the front. Let's do log e of 3 squared, 18. Log e of 18. And then we're subtracting log e of 9. Log e of 9. Okay, now the good thing about that is that I can say, okay, let's simplify this a bit. That's going to be pi on 2. We'll keep the half out the front for the time being, and let's see what we can do over here. That's going to be log e. Using my log laws, that I can do 18 divided by 9, which is log e 2, isn't it? Would you agree? Now, I'll accept that. I would accept that as an answer. But you might want to do the inverse power law, where you bring that half and you bring it in. That would be 2 to the power of a half, which is root 2, isn't it? Pi on 2 plus log e root 2. Now, because doesn't it say, oh, it says here, in the form. So can you see there it says in the form a plus log e of b. So therefore, we can say that a is equal to pi on 2 and b is equal to root 2. If you stopped there, that would be okay for most questions. Okay, if you stopped here, if you stopped here, that would be okay. But you've got to carefully read the question. This form is when b is equal to root 2. Okay? How are we feeling so far?
Can I get a show of hands, the students who've got that correct? People just afraid to put their hand up, or because I only see about 1.5 hands up. Yeah, I saw yours. David, is this a hand up? Or? You're thinking. Okay. All right. Okay. All right. Look, let's keep pushing on, and obviously, hopefully, you take out a fair bit of what we've done today. You can study a little bit more. I'll let you bring in a bound reference to your test. Okay. The one thing I'm not going to let you bring in though is a calculator. Okay. So bound reference, but no calculator, because anyone can work out this out in the calculator. All right. Now, let's have a look at this one here. Sine squared 2x minus cos squared 2x. Can everyone just first of all have a look at how many marks this is worth? 2. So there's going to be a pretty easy method. Now you could do something absolute crazy and split that up into 2 separate ones, but what you might notice is that I believe that cos 2x, isn't that equal to cos squared x minus sine squared x? Is that correct? Double angle formulas, which if you have it committed to memory, these double angle formulas, you'll recognize that. So therefore, would you agree then that if I said that if I had negative cos 2x, what would that be? Negative cos 2x would be sine squared x minus cos squared x. Now, the only difference here is we've got different angles, 2x. So can you see the relationship here, that the thing with the minus cos 2x, so therefore couldn't we say that if I had these angles and I doubled those angles there, if I made that 2x, would you agree then that minus cos 4x would equal to sine squared 2x minus cos squared 2x? Would you agree with that? Yeah? So therefore, you've done the work to the side. Now you can proceed with the question. And of course, if you start considering that you look at it as being worth 2 marks, if you start, look, you could have done it another way, fine, but not to get, it'll take you 10 minutes. Take you 10 minutes to do. So you've got to know, you've got to be able to identify what's the best way to do it. Well, the best way to do it is that I've now can replace that with minus cos 4x. So what we can say is, therefore, this thing is equal to, that's me being lazy, is equal to 0 to pi on 8 of minus cos 4x dx. Isn't that lovely? Now, that's going to be minus sine of 4x. Remember, I'm dividing through by the 4, and that's going to be between pi on 8 and 0. Subbing in pi on 8. So pi on 8 times 4 is sine of pi on 2. Sine of pi on 2 is 1. So that's going to be careful with the negative though, that's going to be negative 1. The 4 didn't go anywhere. Okay, and then what we're doing is we're subtracting, I'm going to do this again, we're subtracting sine of 0. So that's 0, isn't it? So it doesn't really matter, does it? Okay, so in other words, the answer is simply minus 1/4. Minus 1/4. Yes, you can get an integral and you can get a negative answer, but later on when we work out areas and things, areas under curves, you don't get negative area, just so you know, all right? You don't get negative area. You have to use the positive sign when we get to that, and that's going to be in chapter 8, coming up very soon. Okay. Are there any questions? Would you like me to pause this and we can have a little bit of a chat about anything, or would you like me to proceed? Proceed? Okay. Well, we'll keep going then. All right. Now it says use partial fractions. In an exam setting, are you going to be told to use partial fractions? No. No, you will not be told partial fractions. So first of all, what I'm going to do to the side is I always like to just draw myself a little column down here, and I'm going to do the working out first. Forget about the integral, forget about the terminals. What we're going to do is we're going to say that x minus 5 over. Now, of course, the question is this an irreducible quadratic? I don't think it would be. That would factorise to what? X minus 3, x minus 2, wouldn't it? Now, another thing I'll get you to think about is sometimes if the power, because this is of degree 1, because this is degree 1 and this is degree 2, that means that we don't need to do any polynomial division or anything, do we? But can I just ask, what about if the numerator, what happens if that wasn't degree 1? What happens if this was degree 2? What would you have to do? You'd have to do polynomial division first, and then you'd have to do partial fractions. That's probably as hard as it gets. Okay, they don't often make you do it, but they can, and they have done before. All right, so because degree 1 on the top, degree 2 on the bottom, partial fractions. So what we're going to do is that's going to be, now this is just a type 1 partial fraction. They're just linear factors. There's no repeated linear factors. So we're going to go x minus 3. Then we've got plus b, x minus 2, like so. Now we're going to go straight. Now you could literally go straight from there to the answer. And I have no issue, and the examiner, I've marked exams in 2012. I can tell you now that you would not lose a mark if you find A and B correctly without showing any algebra, right? The whole point is, though, is that you want to get it correct, all right? So what I'm going to do is I'm going to say x minus 5 is equal to A, x minus 2 plus B, x minus 3. And I'm going to do it the long way. Let x equal 2, which implies that we've got minus 3 is equal to minus 1 minus b. Is that right? Okay, so b is equal to 3. Then I'm going to let x equal 3. And if x equals 3, we're going to have minus 2 is equal to a. That was easy, wasn't it? So now what we can say is this is where you can't really get sloppy, and I don't want you writing nothing equals something. I want you to physically write it out again, please. I know that it seems quite, laboursome and tedious and things, but what you do is you write that, and that is equivalent to, I need to write that once, that is equivalent to negative 1 to 0, and then let's fill out what we've got over here. We're going to have minus 2 is A, so that's minus 2 over x minus 3 plus 3 over x minus 2. Don't forget that dx. And now, therefore, that is equal to, we can go straight into the formula sheet. That's minus 2 log to the base e of absolute value sign, please, like so, plus 3 log to the base e of absolute value sign, please, like so, and that's between negative 1 and 0. But what we can do is we could probably do a little bit of cleaning up here if we wanted to with our log laws. Or we could just simply sub it in. Up to you, right? Let's just sub it in, shall we? Now, because it's the absolute value sign, what that is I'm going to sub in 0 first. So we've got minus 2 log e to the 3. And then we've got plus
3 log e to the 2. Okay, that's the first one when I do that. And then we're subtracting. I'm sort of running out of room here. So I'm just going to rub this out for the time being. Then we're subtracting negative. Now, we're subtracting negative. So negative 2. We've got negative 1. So log e of negative 1. So that's log e to the 4. And then we're subtracting, it's plus 3 log e to the 3, isn't it? Like so. Okay, now, so let's get this all together and see what happens. So we've got minus 2 log e to the 3 plus 3. This is really good for your log laws too, isn't it? Now, we're subtracting 2, so that's plus 2 log e to the 4. And then we're subtracting 3 log e to the 3. Okay, so now that's actually quite good because I've got the log e to the 3s. I've got negative 5 of them. So we could do that. But I do think that what we're going to have to do is we're going to have to bring these things in. So what I'm going to do is like this over here is log e of 2 cubed, isn't it? Which is 8. And this over here is going to be log e to the 6. Log e to the 16. And of course, then Then I've got minus log e to the so on and so forth. So what we're going to do is I'm going to go and I'm going to simplify this in one step. Or let's see if we can do that. We're adding these two logs, so I can say that's log e to the 16 times 8. 10 eighths is 80, 48, 128. Okay, so log e to the 128. Okay, and then you're subtracting 5. Let's get these in here. Let's get these and simplify these two. Okay, that's going to be minus 5 log e to the 3, isn't it? Which means that I'm going to bring just the 5 in, 3 to the power of 5. 3 to the power of 5 is 243. And what? 3 to the power, well, if you know 3 to the power of 4. Okay. Now, if that, so therefore, and since it's minus, so the answer should be that. Is that what you got? Did you guys get that? Well done. That's not easy, is it? Because there's so many ways in which you can go wrong. So many ways. And as you can see, when they mean log e p can just be any number. Okay? Any real number. Okay? So there's a fair bit of work in that. And by the way, this is not the test that I've just given you. That's not an easy test. I'm going to give you a test probably a little bit easier than this one on Friday. Okay, I promise you that. I promised you I'll give you an easier one, didn't I? Okay, because I gave you a diabolically hard one for complex numbers. It was a crazy. Okay. All right. Did anyone have any questions so far? Do you want me to pause it and we can have a little chat, or do you want me to keep going? Hands up if you want me to keep going, or hands up if you want to. All right, I see enough hands. Okay, thanks. We're all just we're still in holiday mode. Still in holiday mode, guys and girls. Okay, now, Mr. David Dong, what did I say that whenever you see that square root sign, what does that give you an indication of? Substitution, yes, because the thing that's inside the square root, if you let that equal u, then du dx, that's going to mean you can be able to do substitution. So what we're going to do, oh geez, I'm almost tipped the table over. Okay, so first of all, what we're going to do is we're going to let u equal 1 plus x squared.
No. That's silly. What am I doing? Let u equal 1 plus x squared, like so. All right? So, du dx, and you write this. This is exactly how you write it out. And ladies and gentlemen, please, can I just, you may have your own little way of doing these, but can you just copy the way I do it, please? Because when I mark exams and things, students just invent their own little ways and lose marks. So I can just, if you do it my way, you will not lose a mark. I can assure you. Du dx is equal to 2x. Okay, so that's du dx. Now, be careful though. We have terminals, so we have to change terminals around. When x equals 0, u is equal to 1. And when x is equal to 2 root 2, u is equal to, now let me just think about this, 2 root 2 is root 8, so root 8 squared is 8, so that makes that 8 plus 1 is 9. Okay, so that should be 9. Now, therefore, what we can say is I is equal to, you do not change the terminals. You need to do it like this, 2 root 2. Now, what we're going to do is we're going to do now du dx is 2x, but we've got a 4x here. So what we're going to do is I'm going to put a 2 out the front, and that would make that a 4x, wouldn't it? And then what we're going to say is that's going to be the square root of u, and then du dx, like so. Okay? As I've always said, never, ever do anything until you make that substitution and basically have just in terms of u. You need to leave the terminals as they are. So now when you go to du, that is equal to 2, and now you change the terminals. So 0 becomes a 1, and 2 root 2 becomes a 9, and isn't that lovely? Root u, or let's do u to the power of a half, because of course that's just a polynomial, isn't it? Du. Okay, and all of a sudden that becomes really easy, doesn't it? I would hope. So what are we doing to the power? We're adding 1. So that's going to be u to the power of 3 over 2 over 3 over 2. And then don't forget that 2 out the front. So it can get a little bit ugly with fractions and things. And now that's going to be for the terminals 1 to 9. Now I might clean that up just a little bit, because we know that if I have a fraction on the bottom, that denominator, that 2, is going to become the go up the top, isn't it? So let's change that. Let's change that. That's going to be 2u to the power of 3 on 2 over 3. Isn't that wonderful? Now I can go, if I really wanted to, I could take the 2/3 out the front too, couldn't I? I could make my life much easier, and I could make that 4/3, and I could make that u to the power of 3 over 2 to the power of 9 and 1. Now let's evaluate that. That's going to be 4/3 u to the power of, so that's 9 to the power of 3 on 2. Now you're sort of wondering, how would you do that without a calculator? It's pretty easy, isn't it? But we'll get to that in a second. And then minus, well, this is the easy one, minus 1 to the power of 3 on 2. That's the easy one, isn't it? Now, why don't we do this? Okay. Now, let's think about 9 cubed. If I have 9 cubed, 9 times 9 is 81. Right? So we don't really want to do that. So you're wasting your time, and in actual fact, you're more likely to get it wrong, aren't you? So what? Instead of going 9 times 9 times 9 in your head, then what you do is you go and make this 3 squared, and then we've got 3 over 2, like so, and we know that that's 1, isn't it? Oh, I've got a missing that there. Now 2 times 3 over 2 is just 3, isn't it? So that's going to be 27. 27 minus 1 is 26. 26 times 4 is 104. 104 divided by 3 is 104 over 3. Dunskies. Yeah? Cool with that? Not easy questions. I'm not saying this is a really good test of how well you know chapter 7. But if this is making sense, and if you've done the coursework, maybe you need to finish some of the coursework. Okay. All right, ladies and gentlemen, what are we doing for this one? Let's have a think. What are we doing for this one? Because remember that, you know, there's all sorts of ones. If it was just cos squared 2x by itself, that would be different. It would be trig identities. But can someone put their hand up and tell me, what are you doing for this one? Tyler. U. Yes. So not cos squared 2x equals u. U is equal to cos 2x. Yes. And remember, the one which is the higher power, that is the one that you're letting u equal. Okay? So we're going to do that. We're going to do it like this. We're going to let u equal cos 2x, not u cos squared, like so. So therefore, du dx is equal to minus sine 2x, and of course there's a 2 out the front, isn't there? Okay, minus 2 sine of 2x. And as you can see there, we've got a sine 2x, so it's pretty close, but we've got to obviously do some manipulation again. Surprise, surprise. That's what you do virtually in all these questions. You're manipulating. All right, so we have terminals, so we might as well set it up like this. And please, can you set it up this way when I sort of am marking your next test? Can you please set it up something like this? When x is equal to pi on 2, u is equal to cos of pi. -1, isn't it? Okay, so that's good. And when x is equal to 3 pi on 4, u is equal to cos of 6 pi on 4, cos of 3 pi on 2, 0. Okay, nothing wrong with that being 0. Okay, all right, so we've got to start. So therefore what we can say is I is equal to, keep the terminals again, please, like so. And now what we're going to do is we're going to call that u squared. That's fine. We can do that. But what's du dx? Du dx is minus 2 sine 2x. We only have sine 2x. So what's the constant that I should be putting out the front to account for that? -1/2. -1/2. Good. And do that immediately, please. That's fine. Now you can say u squared, and then that means du dx. And then the next line is, now you can change your terminals. That's right. Wherever there's a pi on 2, there's a -1. Wherever there's a 3 pi on 4, there's a 0. That is perfectly fine to do. And now what we've got is, well, we could go, that's just u squared du. And now, isn't that easy peasy, Japanesey? Oh. What have I done? Oh, yes, I did. Yes. Oh, I do that sort of stuff all the time, don't I? That's sort of the brain's working a bit too far ahead. It doesn't actually get you, help you in your exams, I can tell you. If you work too fast, you make mistakes. Yeah? Okay, so now all we have to do is I can put my -1/2 at the front, and that's u cubed on 3 between 0, -1, and that's going to be -1/2 times 0. Now, be careful with your negatives, please. We're subtracting -1 cubed over 3. You're going to have some problems with negatives here. Now, -1 cubed is negative. So that's going to be, but there's a negative in front of it. So it's going to be positive, isn't it? So it's going to be positive 1/3 and then it's going to be times negative a half, which is negative 1/6. And that, ladies and gentlemen, is your answer. That is your answer. Okay, we've got 9 minutes. Let's see how we can do. Look, another substitution one here. I'm not going to really explain it other than just do it. All right? Does someone want to time me? Get the timer out. Ready, set, go. Let x plus 1 equal u. Du dx. Oh, no. Oh, I don't know about this. Oh, this might be a linear substitution. Because if I have u plus 1, doesn't that equal x? So therefore, wouldn't 15 times u plus 1, wouldn't that equal 15x? Is that right? Yeah? So this is a linear substitution. Oh, maybe. So what we're going to do then is, and also we're going to say that let x equal, when x equals minus 1, then u is equal to minus 1 plus 1, which is 0. Yeah, u plus 1 is u minus 1 is equal to x. Yes, yes, yes. U minus 1 is equal to x, so that means that 15, that's going to be 15u minus 1. Cool? Okay. Oh, I'm under the pressure. I'm under the pump here. Now, so if I can get back to that, so when x equals 0, u is equal to 1. Now, therefore, what we can say is I is equal to, keep your thingies the same, and what we're looking for is, we're still looking for the chain rule in reverse. Du dx happens to just be 1, so that's quite nice. But what we can say is 15x is equal to 15u minus 1. And then that's times u to the power of a half du dx, like so. Now I can go ahead and change the terminals. Wherever there's a, just swap. So as a negative 1 becomes a 0. So that becomes 0, and the 0 becomes a 1. And then what we're going to do is we're going to expand those brackets out. 15u times u to the power of a half is 15u to the power of 3 over 2. Okay, so we're going to do that. 15u to the power of 3 over 2, and then that's minus 15u to the power of a half. And we're going to just call that du, isn't it? Yeah? So now we can go ahead and we can proceed and actually. So the hard part though is recognizing that it's a linear substitution. You do a u substitution, you're going to get all, you can't, the derivative of x plus 1 is not 15x. There's no way you can do it. So you're going to lose the marks. So now we're going to go, we're going to add this 15 u to the power of 5 on 2 over 5 on 2 minus 15 u to the power of 3 on 2. Gee, we've got some hard algebra, haven't we? Oh, shut up. Okay. I was telling the computer to shut up, not you guys, by the way. Okay, so 0 to 1, like so. Okay, like so. Now we're going to sub in the 1. Now that's going to be, so that'll make our life a bit easy. But why don't we do this? Why don't we get the 2 on the top, which makes that 30, and the 5 down the bottom, u to the power of 5 on 2, minus 30 over 3, u to the power of 3 on 2, 0 to 1. That's better. Now, if we put in 1, that's going to be 6 minus 10, and then that's going to be minus 0, isn't it? So therefore the answer is that another negative answer? Negative 4. Okay, not an easy one. Did you guys find that tricky when you were doing that? Jack, you look pretty confident there. You got it? Good. Okay. All right. Now, this is sort of like one of those, if you derive this, then you can hence anti-derive this next one. Now, you're going to do a hell of a lot of those sort of things in methods coming up soon, a lot of them. Okay, so for the time being, I'm going to skip that one and then go straight to this one because I've got 4 minutes, okay? 4 minutes. All right, let's see if I can do this in 4 minutes, ladies and gentlemen. First of all, what do you notice? What do you notice about the numerator? The numerator is higher, isn't it? So what we're going to do is if I do this, do a little bit of this, then we're going to have, that's going to be x. Now, whenever you do that, that's going to be x cubed minus x, minus x, minus x, like so. Ooh, minus x. Okay. So what happens now? I subtract this, subtract that. How many remainder do I have? 2 remainder. So therefore, what we can say is that x cubed minus x plus 2 over x squared minus 1 is equal to what? What's that? X. So it is equal to, so we get x plus 2 over our denominator, x squared minus 1. Yes? Which is x minus 1, x plus 1. Correct? So now, let's see if we can do this. The antiderivative of 2 to 3 of x plus 2 over x minus 1, x plus 1. Can you see there that maybe we're better off splitting that up like so? And don't we have to do partial fractions there? Okay. Can someone tell me, in actual fact, I'm going to just have a look at the answers and just so we don't have, because we know how to do those partial fractions. So that's going to be equal to 1 over x minus 1, like so. So using partial fractions, that's going to be 1 over x minus 1 minus 1 over x plus 1. Is that correct? Dx using partial fractions. Now that's going to be x. Please, you try to do this in 1 minute. It's not easy. Okay, that's log e to the x minus 1 minus log e to the x plus 1, and that's between 2 and 3. And when you do that, you work through that. That's going to give you what are we at? We're at 9 over 2 plus log e to the a half minus 2 minus log e to the third. So then when we bring that in, that's going to be 5 over 2. And then we've got log e of a half divided by a third, which is equal to log e to the 3 on 2. So therefore, A is equal to 5 on 2 and B is equal to 3 on 2. So, sorry. All right, now, that's 50 minutes.